Next, we look at some actual examples of using the product rule and the quotient rule. Our first example actually gives us a new derivative rule, and that is y is equal to tangent of x. Now, you might have noticed that tangent of x was not listed in one of my 5 basic derivatives. That's because it really stems from using 2 of the 5 basic derivatives and the quotient rule. Now, you might look at this and think, well, how is it possible that either the product rule or the chain rule or the quotient rule could possibly be involved in this? Well, remember that tangent of x is equal to the sine of x divided by the cosine of x. So the tangent of x is really just a ratio of 2 functions whose derivatives we know. So we can compute the derivative of tangent of x just using the quotient rule. So the quotient rule says that dy dx is the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. So it just rolls off the tongue like that. So bottom is cosine of x times the derivative of the top. Now the derivative of sine is cosine, so cosine of x times cosine of x, and then minus, so that's the bottom times the derivative of the top minus the top times the derivative of the bottom. Now the derivative of cosine is negative sine, so that negative sign changes this minus to a plus. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom, which brings us an extra negative, changing this to a plus, and then divided by the bottom function squared. Now the numerator can be rewritten as cosine squared x plus sine squared x, and then it's divided by cosine squared x. Now cosine squared x plus sine squared x just simplifies to 1. So we have 1 divided by cosine squared x, which is equal to secant square x. So recall, secant of x is 1 divided by cosine of x. This is not equal to cosine negative 1 of x. This is the arc sine of x. So that's the arc, or the arc cosine of x. So whenever you have the minus sign, just a reminder, whenever you have cosine with the minus 1, it refers to the inverse function, not the reciprocal. So it's not cosine of x to the negative first power, it's the inverse function, it's the arc cosine function. So that's the only time when this exponent on the cosine refers to something other than a power. So be aware of that. So secant of x was 1 over cosine of x. 1 over cosine squared is therefore secant squared of x. So the derivative of tangent of x is equal to secant squared x. Now we can even do more. What happens if we have tangent of u of x? Well, we can use the chain rule. So the chain rule says that dy dx is going to be secant squared of u of x, and then times the derivative of the inside, which is u prime of x. So that would be our extended derivative or generalized derivative or derivative plus version of tangent of x. So derivative of tangent is secant squared. The derivative of tangent of u of x is secant squared of u of x times u prime of x. Our next example is an example that will use the product rule. So we'll alternate back and forth product and quotient. So this example is e to the 2x times the sine of 4x. Okay, so the product rule says that dy dx is going to equal the first function, e to the 2x, times the derivative of the second function. So the derivative of sine is cosine. And then we have to multiply by the derivative of the inside, which is 4. So I'm going to put that right out there. And then plus the second function, sine of 4x, times the derivative of the first. The derivative of e to the 2x is e to the 2x times the derivative of the upstairs. So e to the 2x times 2. So it's plus 2e to the 2x. So there you go. The derivative of e to the 2x sine of 4x is 4e to the 2x cosine of 4x plus 2e to the 2x sine of 4x. Our next example is ln of x divided by x. Here we want to use the quotient rule. So the quotient rule says that the derivative is the bottom, which is just x, times the derivative of the top. Derivative of ln of x is 1 over x. And then minus the top, which is just ln of x, times the derivative of the bottom, which is 1. right? Derivative of x is just 1. All divided by the bottom squared. Now we can simplify a little bit. X times 1 over x is just equal to 1. Ln of x times 1 is just equal to ln of x. So it's 1 minus ln of x divided by x squared. So fairly simple derivative. So you can see how easy the quotient rule made that. Next we have another example with the product rule. So this is x times ln of x and then minus x. Now the minus x, you'll see why that's there in a second. And of course, since it's a second term in the equation, we just have to differentiate this separately. So we differentiate x ln of x, and then we differentiate the minus x separately. So the derivative of x ln of x, we use the product rule. So it's the first times the derivative of the second. So it's x times 1 over x, and then plus the second times the derivative of the first. So derivative of x is 1. So that is going to be just the derivative of x ln of x, right? So x ln of x becomes this plus this. And then minus x, so we take the derivative of x, which is just 1, so we get minus 1. So the derivative of x is just the 1. Now when we simplify this, x times 1 over x is just equal to 1, so we get 1 plus ln of x, and then minus 1. So the derivative is just equal to ln of x. So if you were wondering, what function can I differentiate in order to get ln of x? There's your answer. It's x ln of x minus x. Our next example is another quotient rule. So we have sine squared x divided by cosine of x. Okay, so let's see how, and of course there's numerous ways to do this, but let's see how we can do this just using the straight up quotient rule. So bottom times the derivative of the top. So cosine of x times the derivative of sine squared x. Now the derivative of sine squared x, we have to use the quotient rule. It's really sine of x to the power of 2. So the 2 comes down, we get 2 sine of x to the 1, and then times the derivative of the inside. So that will be 2 times sine of x, so there's the inside, and then times the derivative of sine, which is cosine of x. So back to our quotient rule, we had the bottom times the derivative of the top, so it's times the derivative of sine squared x, so it's cosine of x times 2 times sine of x, and times another factor of cosine of x, so we get cosine squared x, and then minus the top, which is sine squared x, times the derivative of the bottom. Now the bottom is cosine of x, its derivative is negative sine of x, so that minus turns this to a positive, and that extra factor of sine changes the sine squared into a sine cubed. And then it's all divided by the bottom squared, so it's divided by cosine squared x. So to simplify, this is equal to 2 sine of x. So this first term, we have cosine squared of x divided by cosine squared x, and then plus, well, the next term we can think about this as sine of x times sine squared of x. Sine squared of x over cosine squared of x is just tangent squared of x, so it's plus sine of x times tangent squared of x. And notice there's a common factor of sine of x, so we can actually even write this as sine of x times 2 plus tangent squared of x, just like that. And our final example is x cubed times the sine of 8x. Product rule. dy dx is the first times the derivative of the second. The derivative of the second, we get 8 cosine 8x, and then plus the second times the derivative of the first, which is 3x squared. So there you go. It's 8x cubed cosine 8x plus 3x squared sine 8x. And so those are some examples of derivatives using the product rule and the chain rule.